Dear students, welcome you all to the industrial pharmacy class. In today lecture, we will discuss the topics related to tablets as well as we will discuss the capsule including hard and soft gelatin capsule. The topics related to tablets that so far we have discussed in the previous weeks are different processing problems regarding the tablets, but today we will discuss the tablet coating. The main focus is to learn about the coatings and that why coating is done for the tablets and what is encapsulation and the different types of encapsulation. Dear student, after the completion of today's lecture, you will be able to learn about the tablet coating and there are different types of the coating and the main objectives behind the coating of tablets. And the second part of the lecture, that after completion of this lecture you will be able to learn about the hard and soft gelatin capsule. Let's discuss from the definition starting, that is tablet coating. That what is meant by tablet coating. Tablet coating can be defined as the process of the application of coating material to the exterior of a tablet with the intention of conferring benefits and properties the dosage form over the uncoated variety. You can see in this definition that tablet coating means the application of coating material over the tablets, but the purpose of this application of the coating material over the external surface of the tablet is to give extra benefits and properties which is not present in the uncoated tablets. On one side, one is uncoated tablets and we are going to apply the coating material over that uncoated tablet, and by applying the coated material to the exterior of uncoated tablet, we aim to give benefits which are not present in the uncoated tablet, and we want to enhance certain properties which are not found in the uncoated tablets. There are different reasons of the tablet coating or the objectives of the tablet coating. Some of the objectives are given as to cover the unpleasant taste and odor of the color of the tablet. If some tablets having unpleasant taste of the drug, the formulation, and we want to cover this unpleasant taste, we want to mask this one, we have to coat the tablets. We have to apply the coating material over the tablet in order to remove the unpleasant taste or better taste of the drug. If some unpleasant odor and color which is not good, in these cases the tablets are coated. The coating material are applied over the tablet to cover these problems associated with the tablet dosage form, which is found in the uncoated variety, but we have to mask the taste and we have to mask the odor, and as well as we have to alter its color. The second objective is physical and chemical protection of the drug from environment. If we want to protect the drug from the external environment like the light, moisture and air, in this case we will process the tablet coating in order to physically and chemical protection of the drug from the environmental condition. In certain cases if you want to control the drug release from the tablets, we have to coat according to the control of the drug release. Suppose we want to protect it from the acidic environment, the drug release is protected from the acidic environment, that is the gastric environment. In this case, enteric coating is done. If you want to retard the release of the drug, release retardant material or cover is applied over the external surface or exterior of the tablet in order to retard the release. Or sustained release are more usually to coated multi-particulates. In these cases, when we want to control the release of the drug, we have to coat depend upon the purpose of drug release. Either enteric coating is done or sustained release retardant material is coated over the tablet in order to get the sustained release tablets. To protect a drug from the gastric environment of the stomach, in this case the gastro-resistant coat is covered over the tablet, and this is also termed as acid-resistant enteric coating is done in order to give protection of the drug from the gastric acidic environment. In certain cases, if you want to improve the appearance of tablets, the coating is done like film coating. And tablet coating is also done for assisting and facilitating the identification of the drug. Different colors of film are coated in order to assess and facilitate the identification of the drug. Now, in this part of the lecture, we will discuss the primary components involved in the tablet coating. There are three primary components involved in the tablet coating. Depend upon the tablet properties, that what is the lack of the properties and characteristics which are not found in the uncoated variety, and what is the purpose of our coating, and what are the present characteristic properties in uncoated varieties. So this is one of the primary component, that is the tablet properties we have to consider. The coating process, that the coating equipment, that is selection, that we have to select the appropriate and relevant coating equipment, and the parameters of the coating process, facility and necessary equipment, automation in the coating process, and coating composition. Coating composition includes that what is the nature and what is the purpose of the coating, and on the basis of that we have to select the appropriate coating composition and that formulation, and it is prepared, the coating composition is prepared, either we have to film coating application, or sugar coating application, or the enteric coated application, or the sustained release retardant material application over the uncoated tablet in order to get the certain properties which are not present in the uncoated variety. So the coating composition is also important. Now in this session we will also discuss the tablet properties for coating. Every tablet cannot be coated and not easy to coat, so the tablet properties for coating must be considered prior to coating the tablets. The tablets that are to be coated must possess the proper physical characteristic, and upon this criteria we have to process the tablet for coating, and some of the physical characteristic includes that we must consider before going to properly coat the tablet. The first one is to tolerate the intense attrition of tablet striking other tablets or the walls of the coating equipment. The tablet must be resistant to abrasion and chipping. Recalling from the previous week lecture in which we discuss the processing problem like quaking, capping, lamination. In case of the tablet coating, the tablets are exposed to certain attrition and attrition forces during the striking with one another or striking of the tablets with the walls of the coating pan or coating equipment. The tablets have the potential to tolerate the intense attrition of the tablet during this processing of the striking with one another or the walls of the coating equipment. Tablet surfaces that are brittle, softened, and the presence of heat are unacceptable for film coating. If we have tablets, their surfaces are brittle, and upon the application of the heat during the process of coating, they become softened. They are not eligible to process for the coating. So, the tablet surfaces must be also considered. Is it suitable for the coating or not? The tablet must have smooth surfaces free from any imperfection. If these are not smooth, then it is not easy to coat properly over the uncoated variety. Certain other properties including the physical shape of the tablet, it is of prime importance. The ideal shape for coating of the tablet is spherical shape. It is the ideal shape which allows the tablet to roll freely and the coating pan with minimum tablet to tablet contact, while the worst shape for the tablet coating is the plate face tablet. The plate face tablets are not easily coating and the spherical shape is the ideal one. For this reason, coated tablets have rounded surfaces. The more convex the surface, the few difficulties will be encountered with tablet agglomeration. Another factor we must consider and qualities are characteristic, that is hydrophobic tablet surfaces are difficult to coat with the aqueous based coating because it is not easy to cover the hydrophobic tablet surfaces by using the aqueous based coating. Because of the difficulty will be experienced in the wetting of the hydrophobic tablet surface with the aqueous based coating. Addition of surfactant improves this adhesion, and by using appropriate concentration of these relevant surfactants, we can coat the aqueous based coating over the hydrophobic tablet surfaces. There are different types of tablet coating, and various kinds of tablet coating include sugar coating, film coating, enteric coating, and press coating. Now we will discuss in detail the sugar coating. As the name indicates, that it involves the application of coating, but in this case that is the sugar solution with the color for several times to give a uniform and elegant film. Advantages of the sugar coating include it prevents the unpleasant odor and gives sweet taste, that is to the unpleasant or better taste drug we have to cover the better taste of the drug. So by application of the sugar coating, the tablets gain the sweet taste and unpleasant or better tasted marked by this trick. Another advantage is highly elegant and gloss tablets are obtained. There are different steps involved in the sugar coating of tablets, but few steps which are of prime importance, including the first one is sealing or seal coating, the second subcoating, third step is syruping or smoothing, and the last one, that is polishing. Now we will discuss one by one the different steps. The first one is sealing or seal coating. It prevents moisture penetration to the tablet core. Remember that the tablets without the coat, that is termed as core of the tablets or body of the tablet. Seal coating agents or sealant include shellac, zeal, folic acid, PG 4000, that is polyethylene glycol 4000, alcohol, methylene chloride. These are the different seal coating agents. In case of the zeal, that is alcohol soluble protein derivative, shellac, that is more effective because of the polymerization of shellac. But shellac lengthens the tablet disintegration and dissolution time on aging. That is one of the drawback side effects of the shellac if we use. So zinc is preferred, that is alcohol soluble protein derivative than shellac. And why we have to choose the zinc rather than the shellac? Because in case of the using the shellac, although it is more effective, but lengthening time of the disintegration and ultimately the dissolution time because of the polymerization of the shellac with the agent, that is reported. The second step, that is termed as subcoating. A subcoating is applied to form uniform agent, and second one is the subcoating application is to build up the tablet size. Subcoating process, that is the application to form the uniform edges as well as to build up the tablet size. The desired size of the tablet is achieved by this step by application of the subcoating material. Subcoating increases the tablet weight from 50 to 100%. Examples of the subcoating materials are gelatin, sugar coating, material also included in this part, that is sugar cane powder, corn syrup and gamification. Subcoating involves the application of binder solution to the tablets followed by dusting of subcoating. In the first step we have to apply the binder solution for the tablet core and then followed by dusting of subcoating with powders and drying until the tablet edges have been covered and the desired thickness is achieved. The third step, that is termed as syruping, which is also termed as smoothing. It is done to cover the imperfections in the tablet surface caused during subcoating step. It involves application of syrup coating with gaussing syrup followed by the addition of dilute colorant to provide tinted base, and after that in subsequent step the syrup solution containing dye are applied until final size and color are achieved. The final step is a clear syrup coat without dye are applied. The fourth step is termed as polishing. The desired luster to the tablet is obtained by polishing. Tablets are polished in a standard coating pump by application of carnauba wax. It is yellow in color, beeswax is white in color, and paraffin wax are warm solutions of waxes, and naphtha or other suitable volatile solvents. The volatile solvents we use in this step, that is evaporated, and by this way the tablets are polished in a standard coating pump. Another types of tablet coating, that is termed as film coating. Film coating is a more contemporary and a commonly used process for coating oral dosage form like tablets. It involves application of a thin film to the surface of tablet capsule or multiple core. But in this case, we are studying about the film coating over the tablet. Types of film coating. Film coating may be classified in a number of ways, but it is common practice to do so in terms of intended effect of the applied coating on the drug release characteristic that I have told you, that the selection of the coating material and the coating composition will depend upon the objectives of the coating. So the drug release characteristic, on the basis of drug release characteristic, applied coating, the film coating can be classified. The first one is immediate release film coating, also known as non-functional coating. The second one is modified release film coating, also known as functional coating. The first one is immediate release, also known as non-functional. The second one is modified release, that is modification of the conventional dosage form, and also termed as functional coating. Immediate release film coating, which is also termed as non-functional coating. This is something of a misnomer, as this terminology refers to the fact that the coating has no measurable effect on biopharmaceutical properties. However, all coating, as explained earlier, have many other properties and functions. Modified release film coating, also known as functional coating. These may be further categorized as either delayed release, that is gastro resistant, or extended release coating. Note that the new term gastro resistant coating is replacing the older term enteric coating and pharmacopoeia. Now, in this part of the lecture, we will discuss a new chapter, that is hard and soft gelatin capsules. First of all, we have to a brief discussion over the introduction of the capsule. The word capsule is derived from the Latin capsula, meaning a small box. In current English usage, it is applied to many different objects, ranging from flowers to spacecraft and pharmacy. The word capsule is used to describe an edible package made from gelatin or other suitable material which is filled with drugs to produce a unit dosage form, mainly for the oral use. Remember that not only the gelatin but also other suitable material can be used for this purpose. Manufacture of the capsule involves dipping metal mold pens into solution of polymer, film form on the mold surface, or dried cut to length, and two parts assembled. Traditionally, hard gelatin capsules are made from gelatin and now also from hybromellose, that is hydroxypropyl methyl cellulose. They can be filled with formulation having a wide range of properties, from a dry solid to non-aqueous liquid. We can fill the formulation. There are two types of capsule. The first one is hard gelatin capsule, the second one is soft gelatin capsule. Better adjectives would be 2-piece for the hard gelatin capsule, and in case of the soft gelatin capsule, the better adjective, if we use it as one piece in place of the soft. The hard capsule consists of two pieces in the form of cylinders closed at one end. The shorter piece, that is called as cap. Remember that the shorter one, that is cap, fits over the open end of the longer piece, and the longer piece is called as the body. In the body, the material is filled, the formulation is filled, and then the caps is fits over the longer piece or the body. Soft gelatin capsules are one-piece form that encase a predetermined dose of liquid or semi-liquid film, filled and hermetically sealed in a single operation. Now, difference between the hard and soft gelatin capsules. There are a number of differences between the hard gelatin and soft gelatin capsules, and some of the differences include the major difference is the Hard gelatin capsules are commonly used for powders. Granules are solid fill, while soft gelatin capsules are used for semi-solid, while the hard one is not used for the semi-solid. Oil, it is not used for the oil or liquid fill. So that is the one of the difference that by using the hard gelatin capsule, powder, granules or solid can be filled. By using the soft gelatin capsule, semi-solid, oil or liquid can be filled. Hard gelatin capsules are prepared in two parts consisting of a body and a cap, while soft gelatin capsules are prepared as a single piece of gelatin. That I have told you about the one piece and two piece for the hard gelatin as well as the soft gelatin capsule as adjective. The ratio of gelatin and plasticizers are used in hard gelatin capsule as 0.4 to 1, while in soft gelatin that is 0.8 to 1. So it is clarified from this statement that plasticizer are used, that is in the soft gelatin is more compared to we use in the hard gelatin. Hard gelatin capsules have different sizes, while soft gelatin capsules are available in some limited sizes. A variety of processes and machines are used in manufacture of hard gelatin capsule, while a variety of processes and machines are used not required to manufacture of the soft gelatin capsule. Hard gelatin capsules are prepared of hard gelatin, plasticizer, coloring, and titanium dioxide, where in case of the soft gelatin capsule, which is made up of soft gelatin, preservative, sugars, plasticizer, coloring, and OPC5. In case of the hard gelatin capsules are generally available in a cylindrical shape, while on the other hand the soft gelatin capsules are available in oval, round and tube-like shape. That is the difference between the hard and soft gelatin capsule shapes. Hard gelatin capsules are unlikely to leak, but soft gelatin capsules have a greater risk of leak because of the one piece and as well as the contents, that is semi-solid and liquid. The leakage chances is greater risk of the leakage in case of the soft gelatin compared to the hard gelatin. Raw material. The raw material used in manufacture of both types of capsules are similar. Both contain gelatin, water, colorants, and optional materials such as processed and preservatives. In addition, soft gelatin contains various plasticizers. The major pharmacopoeias like European, Japanese, and US permit the use of gelatin or other suitable material, and in recent years, hard capsules have been manufactured also from HPMC, that is hydroxypropyl methyl cellulose, in order to produce a shell with a low moisture content. Now that's about the gelatin. It is a major component of the capsule. The selection or the reason of this is that gelatin possesses 5 basic properties like non-toxicity, widely used in the foodstuff and acceptable for use worldwide. And the second reason is that it is readily soluble in biological fluid at body temperature, so there is no problem in the solubility, but dissolution in the body temperature. It is a good film forming material, producing a strong flexible film. The wall thickness of a hard gelatin capsule is about 100 micron. Solution of high concentration, that is 40% weight by volume, are mobile at 50 degrees centigrade. Other biological polymers such as agar are not. That is another reason of the selection of the gelatin for capsule as a major part. A solution in water or in water plasticizer blend undergoes a reversible change from a solid to gel at temperature only a few degrees above ambient temperature, which is termed as isotropic property. This is in contrast to other film formed on dosage form, where either volatile solvents or large quantities of heat are required to cause this change of state. For example, tablet film coating. Now, these films are formed by spraying and have a structure that could be described as a form of overlapping plates where the gelatin films are homogeneous in structure, which gives them their strength. Gelatin is a substance of natural origin that does not occur as such in nature. It is prepared by hydrolysis of collagen, which is the main protein constituent of connective tissue. Animal skins and bones are the raw material used for the manufacture of the gelatin. There are two main types of the gelatin, type A and type B. Type A is produced by acid hydrolysis, type B is by basic hydrolysis. The acid process takes about 7 to 10 days and is used mainly for animal skins because they require less pre-treatment than do bone. The basic process takes about 10 times as long and is used mainly for bovine bone. The bones must first be decalcified by washing in acid to give a soft sponge-like material called osin. Calcium phosphates are produced as a byproduct. That is a little bit about the preparation and treatment. After hydrolysis, the gelatin is extracted from the treated material using hot water. The first extract contains the gelatin with the highest physical properties, and as the temperature is raised, the quality of the gelatin falls. The resulting weak solution of gelatin is concentrated in a series of evaporators and then chilled to form a gel. This gel is then extruded to form strands, which are then dried in a fluidizable drying system. The dried material is graded and then blended to meet the various specifications required. The property of gelatin that are most important to capsule manufacture are the bloom strength and the viscosity. Bloom strength means it is a measure of gel rigidity. A gel is rigid or not. It is determined by preparing a standard gel that is 6.6% weight by volume and maturing at a temperature 10 degrees centigrade. It is defined as the load in grams required to push a standard plunger 4 millimeter into the gel. The gelatin used in hard capsule manufacture is of a higher bloom strength, it is 200 to 250 gram, than that used for soft capsule having the value that is 150 gram because a more rigid film is required for the manufacturing process. That is a table about the capsule size and body volume from 0 to 4, and the body volume in milliliter. 0 is the largest one, having capacity of the body volume 0.69 ml, and the last one that is smallest, that is 4.2 ml capacity. Capsule filling machine. The same set of basic operation performed with the capsule are being filled on the bench for extemporaneous dispensing or on high-speed automatic machine for the large scale, that is industrial production. The major difference between the mini method available is the way in which the dose of material is measured into the capsule body. Manual or automatic machines are used for encapsulation of formulation. Reference is consulted for this purpose. This is Lackman, the theory and practice of industrial pharmacy and modern pharmaceutic, the design and manufacture of medicine, 5th edition. Thank you for your attention.